Hi there, I'm Ben, your daily math teacher. Today we're going to be going over some basic AB calculus problems. Oh! Actually, they're not that basic. They are quite complicated, but the good news is we're going to go over them right here, right now, for you to understand. Imagine it's that dreadful Wednesday, the day of the AP test. You walk into class, you sit down, you open the booklet. What does it want from me? The volume of a solid bounded by the curves? There's 3 curves? Oh! It's actually not that complicated. All you have to do is follow Benjamin's #1 rule. Always draw a graph. So let's begin with a basic X and Y axis. Then let's look at our first curve. Y equals the square root of x. Oh, that is just a basic parabola. Okay, now our second curve, y equals 0. Now that is just the x-axis. Finally, x equals 4. Every point which has 4 as the x value. So a vertical line going down at the point x equals 4. Okay. Now the question tells us that the solid is revolving about the y-axis. So this is going around the y-axis. So let's shade in our region real quick. There we go. So if this region is revolving around the y-axis, it revolves across over, so this region is reflected on the other side. And also, if it is revolving about a singular point, that makes a circle. So right here, this right here makes a circle with the radius being the x value from here all the way to here. And there you have it. Now we have our graph. So let's take a closer look at the cylindrical shell. So to find the volume of the solid, we must find the volume of each cylindrical shell and add them up. This is easier done when we unfold the cylindrical shell itself. So looking at the unfolded cylindrical shell, we can see that it is a rectangle, or a rectangular slab. Now, the height of this rectangle is still the height of the cylindrical shell, so it's still h. Now, the width of the rectangle is the circumference of the cylindrical shell, because when you unfold it, this whole circumference right here becomes the width. And the equation for circumference would be 2 pi r. Now, there's one more dimension to this rectangular slab, and that is the depth or the thickness of the slab itself. This is represented as dx. So, when we find the volume of the slab, we just multiply all these parts together. 2 pi r times h times dx. Now, to find every single cylindrical shell added together, we must take the integral from 0 to 4 of our surface area, of our equation for the volume of the slab. So, volume of the solid equals integral 0 to 4 of 2 pi r times h times dx. Okay, so our radius of the cylindrical shell, as we can see here on the drawing, is just the x value for that point where the cylindrical shell is drawn. It's just the x value. So we can replace r with x. It's 2 pi x times, now the h, the height, is just the y value. It's just the y value at that point. Now the y value is given here and given in the question as the square root of x. So instead of putting in y into our equation, we will plug in the square root of x. X times d of x. Then there we have our equation, which we will solve with basic algebra skills. So our first step is going to be to pull out the 2 pi outside the integral. Here, 4 x square root x dx. Now, finding the integral of x times the square root of x is quite difficult. So what we're going to do is we're going to combine x and the square root of x into one variable. So we know that the square root of x is the same as x to the 1/2. So when we multiply two same variables with two different exponents, we just add the exponents. So 1/2 plus x to the 1 is x to 3/2. So integral from 0 to 4, x 3/2 d of x. Now we must integrate. When we're integrating, we know that we just add 1 to the exponent, right? Times x to the 5/2. But then we must also divide by that new exponent. 2 from 0 to 4. Boom. Now, a not well prepared 9th grader in Algebra 1 might use a calculator to solve this equation. But the very intelligent Ben students who have practiced this for years, we'll just do it in their head real quick. So, 2 pi x 4 oh, we got it. 25.6 pi. Now, don't forget your units. Equals 25.6 pi units cubed, or 80.435 units cubed. Thank you, and that's how you use the cylindrical shell method. Good luck on your test.